So this is the next topic on this course, rivet and bolt connections with basic strength calculations. So within this course we're going to do some simple bolt and rivet calculations. In this course we're going to make some simplifications. More detailed information on how to calculate bolt and rivet connections are described in, for example, in SFS EN 1993, which is called Eurocode basically. The part 8 of the Eurocode, it describes the joint design of joints and how the rivets and bolts are calculated. In this course we're going to focus on the calculation of basic shear stress, and the calculation will be done using this basic formula here. And also we're going to talk about surface pressure, which is affecting on the surface of bolts and rivets. This is the formula which we are going to be using within this course. In coming few slides I will be introducing you some basic joint types of riveted and bolted joints, and then also some terms related to those, and also we're going to talk about the surface pressure. So far we've been doing calculations for basic shear cases. We have had some basic designs like glued joint, and we have also had some welded joints. Now we're talking about shear of bolts and rivets. Here we have an example image of so-called single shear joint, which basically is that there is one plane along which the shearing will happen. Okay, so for example, in this instance we have two plates of steel that are joined together using these three bolts which are visible in this image, and when the load is applied there's a shear between those two plates and it wants to shear those bolts in two pieces. So the free body diagram in this case for the shear force would be one force to the right hand side here, and then each of these bolts will have a shearing surface here, so each of these bolts has a shear force. Within this course we assume that the load is equally divided between the shearing surfaces. So for example, in this case we have three bolts, so we have three shear forces, and therefore each of the shear forces is 1/3 of the force that is pointing to the right. In real life practical applications it might be in some cases that, for example, the holes in the plates are not perfectly aligned, which means that some of the bolts or one of the bolts might be carrying more shear load than others. But within this course and within basic calculation methods we always assume that the forces are divided equally. So this here is so-called single shear case. Well, then we also have these so-called double shear connections, where we have three plates which are connected together using bolts. There's two plates that are sandwiching third plate in between, and in this example we also have three bolts. And now in this case we have two planes along which shearing will happen at the same time. What this means in practice is that the shear force in each of these bolts in this instance would be 1/6 of the total external force that is applied to the structure. Then we have these cases where the forces are not aligned. So up until this point the forces have always been aligned with the force with the connection type, whether it is glue or whether it's weld or bolts. But in this case the force is not aligned. Instead the force in this case is affecting over here, and the bolt connection is on over here. In this case what we have to do in these calculations in this course is that we must move this force into the middle of these bolted joints, and when we move force like so, you know from mechanics, basic mechanics, that when we do the moving we must introduce here torque. In this case the torque would be force multiplied by the distance which we did moved the force, and in this case it would be the L, so FL. So now we have simplified this load case so that we have torque FL, and then we have also still, of course, the horizontal, the vertical force F affecting in here. Same thing applies in here, even though when we move the force, the same force is equally distributed between all those bolts. So let's take a closer look at this example. So now that we did the moving of the force, we moved the force over here, and we have now here the torque FL and also the vertical force F. What is actually happening in here is that the torque is causing here, the torque in here is causing here force, like so, which is perpendicular to the center point where the force is, like so. And the similar force is at each of these bolts. So each of the bolts has the similar and same magnitude of force caused by the torque. We will be talking about this more in details in the practical examples, but here you have the basic understanding what will happen in these cases. What about the surface pressure? So the surface pressure is a new thing within this course. The surface pressure is affecting on the surface, the cylindrical surface of the bolt. So you can imagine that when we have this kind of double shear example, and we have the bolts which go through this middle plate, and there's a force, shear force on both ends of the bolt here, or on both shearing surfaces there. It means that the bolt is basically pushed against the hole in the plate. And this contact between the bolt and the plate is the surface pressure that is affecting on the bolt. In this example, we have drawn a free body diagram of a sheared bolt. So we took one of the sections of the bolt from this hole, and we draw a free body diagram. So we have the force, the shear force on both ends, and then is the force that is basically the reaction between the bolt and the hole in the plate. So now from that we can solve that the surface pressure in this example would be 2 times the shear force. And now when we know the surface pressure force, we can calculate from that surface pressure force the actual surface pressure. In real life, the surface pressure in a cylindrical surface on a round hole, so if we have a round bolt inserted in a round hole, the surface pressure would get shape like this. It would be parabolic shape, and with our basic calculation methods we are not capable of doing such calculations. We cannot calculate this shape, and therefore we use a simplification where the force which is affecting is divided by the area, projected area of this bolt. So in this example, for example, the diameter, this would be the diameter, and then the h will be the length of the part, or in this case the length of the bolt which is inside the plate. Also, this topic will be discussed in more in details when we do the examples, so you will understand this topic a little better. So those were the things for the theory for this time, and good luck with the exercises.